So we went to the second question. I'm going to take the data, my numbers, and I'm going to copy it onto this sheet so that we can work through it. All right, so 0.935. Well, they randomize.
I know, but our numbers are 7.5, 8.5, 10.1, 12.1.
Yeah.
It's really just one other.
Yeah. All right. Now we go through the same process that we did yesterday. The only thing that's different is that the form in which this is written in. Yesterday we had to do this multiplication to write out the answer. Okay, today you don't. You're going to keep it separate. So do it just like yesterday then. Let's get your midline and your amplitude by finding the biggest and the smallest. Okay, so let's see. Largest 17. So for me it was July, and then the lowest looks like January. Okay. All right, so amplitude is going to be the difference of those two divided by 2. And the vertical shift or midline is going to be the sum of these two divided by 2. Do that. Okay, so I got 4.35. 5. $13.25. Okay. So what this table is showing you is the number of daylight hours in a city each month. Okay. Let X equal 1 represent January. Let Y represent the number of daylight hours in the city in the month X. So if I said X was 2, that would be what's the average daylight? How many hours of daylight do you have in February? 9.5. Find a function that models the hours of daylight throughout the year. Okay, so to get the period on this, normally we look for the time between two successive, and this was for like high tides. But since this is measuring the temperature for the entire year, your period is automatically going to be, in this case, 12 months. So we don't look for two highs and find how many months are between the two highs on this. Since it's measuring daylight for a whole year, then a period is 12 months. So any problem like this, anything that's measuring data throughout an entire year, and it's taking one data point for each month, then your period is automatically 12 months. All right, so now to get the frequency, okay, so in this problem, it's going to be in radians, okay? And I'll just let you, if we're doing this like when we test on this, I'll tell you, this one's in radians, so use radians. So to get the frequency B, we're going to take 2 pi and divide it by the period, which is 12 months. So, yep, B is pi over 6. Nope, just leave it like that. And the reason is, when you look at the instructions here, it's saying type integers or decimals, type an exact answer when using pi. So that tells you you're not going to multiply it out, because it says put in the exact answer in terms when you're working with pi's. All right, so back to this. Now all we need is the phase shift. Okay, so to get the phase shift, phase shift. Okay, divide the period by 4. Let's see, so this is going to be 12 divided by 4, which is 3. And on this problem, the first phase shift is, I don't think we have to do a phase shift. Let's look. So our period here starts at January, and we're starting at January. Yeah, there's no phase shift on this. I'm going to show you why here. All right, that's what we just did. We got the highest and the lowest. Okay. Then we got our amplitude. And then we got our midline by adding them and dividing by 2. Okay, then we did the B value, pi over 6. Okay. All right, now here's our function that models the daylight hours for the year. Okay, so far, except it doesn't have C in it. Okay, so now if we go to the next part, okay, the horizontal unshifted graph if you put it on, this would be our normal graph in red and pink here. All right. And if you superimpose it on the graph of the data, okay, shown at the right, our unshifted graph, okay, so the unshifted graph is the one that's in pink. Okay, it must be shifted it to the right to fit the plotted data. Okay, now what that means is we're saying that when we divided 12 by 4, we got 3 months. So our high should be at 3 months. But the high of the actual data isn't at 3 months. So we've got to take this graph and slide it over to the blue graph so that they match. Okay, so the way that we do that is this right here. Okay, so this means at month 3, we should have a max. Okay, that's if we just did an unshifted sine graph. Unshifted sine graph. But our data, when is the first max in our data? So this is month 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our shift occurs at 7. Okay, that's our first max. 7 months. This is 3 months. Okay, so what we did was subtract what we got, 3, from the data's first max. So what I'm going to do is, here's the data's first max. Here's the theoretical first max. There's my shift. So I've got to shift 4 months to the right. So I would write that as x minus 4. Remember the minus, bizarro world? This moves it 4 right. And now so this part right here is going to be x minus 4. And you don't have to multiply that out on this one. Okay, so the difference between these two guys, if it said this instead, if you look right here, plus d. If it said write it in this form instead of this one, then what you would do is you'd go pi over 6 times x, and you would do pi over 6 times 4. 4 pi over 6, which is 2 pi over 3, minus 2 pi over 3. That's how you would write it if the question said put it in this form. You have to distribute. But in this one, it doesn't say to do that. I'm just trying to show you the difference between the two forms. So now we just type this formula in. Okay. We're going to get, let's see. So 4.35, all right, sine. parentheses. Pi over 6. Where are you, pi? Pi over 6. What's that?
So we heard we'll call it knocking, and then Papa said that it was dumb.
Oh. Oh. X. Okay, so then this is parentheses. X minus 4. Plus D, which is 1325. I don't know if there's a difference between using the brackets and the parentheses. There shouldn't be, but okay, and there's our solution. Did you find something wrong, or you got it? Cool. Yeah, it's just one of those things with Math Excel. I probably won't use that question on the test because I don't want people just to go bonkers trying to get one decimal point correct. All right, so what you're going to do for tomorrow, guys, is do the second review, which is right here.